Hi and welcome. Today I'm going to talk about what you can do in situation where you want to calibrate a material to uniaxial tension or compression data, and you happen to have not only the test data from the tension test but also the transverse strain data itself. So if you have axial strain and the transverse strain, can you use the transverse strain in the calibration? It turns out that's very easy to do, and it's also very powerful in order for you to calibrate a very accurate material. So I'll show you how to do that today. So I have some experimental data here. I'm going to open that up with the text editor. We see that the three columns in these files, they're time, engineering strain, and engineering stress. And then the fourth column is transverse strain. And my goal here is to take this data. I'm going to just copy it to the clipboard. Then I'm going to open Calibration. And then when I have Calibration, I'm just going to paste in the data here. And so here are my three tension test curves. If I open the first one here, you can see that there's engineering strain, engineering stress, strain control. What's more interesting is if I look at the raw experimental data itself, but edit the experimental data, we'll see that the column 4 here is the transverse engineering strain. And I want to use this information as part of my calibration. And one way to do that is to simply just read it in, but then you should also activate a fitness weight for the transverse strain data. And that you do under the load case dialog in fitness weights. In this case, I'm just going to pick a value of 1. You have to pick a fitness weight that is suitable for your situation. If you have a fitness weight that is too small, it wouldn't really make much of a difference. And if it's too large, then that's really all that matters in the calibration. But now Calibration will know about the transverse strain. It will use that information when it calibrates the material. So here's an example. It's a thermoplastic material. I have to just pick a material model now. It's going to pick a polyimide TNV model, isotropic thermoplastic material. And this is a very good material model for thermoplastics that I've talked about in many of my other videos. If I simply run this calibration from this point, we get the calibration that is not super exciting. It's sort of a good guess, I guess, but you could certainly improve this by running the calibration here. What I want to do, though, is I want to focus here on the transverse strain. So I'm going to plot here, let's plot two graphs. On the right-hand side, I'm going to plot on the y-axis the true Poisson's ratio. We'll see that the experimentally calculated Poisson's ratio from the transverse strain is, in this case, around 0.2, slightly less than 0.2. And many materials, viscoplastic materials, predict a pretty high Poisson's ratio, 0.4, 0.5, depending on the parameters, of course. In this case, with the TNV model, we can match the transverse strain data if we allow the software to optimize. So I'm going to search for kappa 1, I'm going to search for kappa 2 for all of these three networks. So there are three sets of those. And the second thing I want to do is I want to allow this specific material to have viscoplastic volumetric flow. And I can allow that by setting the BB parameter here. I search for that. There are two of them, one for each viscoplastic network. Now I have a material that will give me the ability to match both the tension data and the Poisson's ratio data, which is really cool. So I can start running this calibration here. To save time, I already performed this, so I'm going to open my saved answer. And here's my saved answer. If I click it on once here, you see it matches the uniaxial tension data at 3 strain rates, but it also does a fantastic job at predicting the Poisson's ratio as a function of strain. As you notice here, this material has a strain-dependent Poisson's ratio. So you need a pretty sophisticated material to match that if that's something you're interested in. Anyway, that's what I wanted to show in this video. You can use transverse strain data very quickly and accurately in your material calibration, and then you need to select a good material that can match the data, obviously. If you have any questions, you can ask them below.